where we found the zeros of equations and they were the solutions of the equation. So we're doing the same thing, but we're using quadratics now. So if you think about the zeros, tell me what the zeros of a function are. X-intercepts. It's where it crosses the x-axis. What is always true at x-intercepts? Y equals 0. Y always equals 0. The sign of the function does change at the zeros, though, from negative to positive or positive to negative. All right, so here's what happens if we have this equation. Let's say f of x equals x squared minus x minus 6. If I told you that this equation equals 0, and I said solve it for x, yeah. Well, you could do that, and we're gonna get to that. That's gonna be the very, very last thing we do. We're gonna solve these by graphing. We're gonna solve them by graphing. So look, if I've replaced y with 0, right? Then graphically speaking, my answer is where? Exactly. Your solution would be the zeros or the x-intercepts. So that's exactly what I'm going to do. We will, but not yet. That's algebraically. We're going to talk about all the different ways to solve. Today is just graphically. We're going to put it in the calculator and see where it crosses. Yeah. All what?
Graphically, but she made the I.
Oh, yeah, sorry. I don't know why it never picks up the bottom of my eye. So graphically what this looks like, because the point is right now, except for Lizzie, you don't know how to solve this algebraically, okay? You don't know how to get that x by itself. You can't SAD map your way out of that, and you can't solve it and get it down by itself. So what we're going to do is we're going to look at the graph itself and find where it crosses the x-axis, okay? So let's see how we do that. Y'all ready? Ray or not. I'm going to pull up my fancy calculator, yes. All right, I have x squared minus x minus 6, okay? When does this equal 0? So I'm going to look at the graph. And I'm going to calculate the zeros. Remember, we've already done this. This is nothing new, right? We did some analysis where we found the zeros of the function. So again, second trace, G-solve if you're on a Casio. I'm going to do the 0. Left bound. Everybody remembers how to do this, right?
Yes, ma'am.
Okay. Left bound, right bound, and enter. One solution is -2. Ooh. But I have 2 solutions. Do you see this? There are 2 values that make this equation true, that make it equal 0. So I go over to the other one, 0. Yes, ma'am. You shouldn't have it. You may have put something in wrong in your initial equation. Check and make sure your equation is correct. X squared minus x minus 6. Same thing, second trace 0, and then left bound, right bound, enter. Just finding the zeros here, yep. And algebraically, you understand why there's 2 answers, right? If I had x squared minus 9 equals 0, and I added 9, well, what's the square root of 9? Plus or minus 3, right? You can do the positive or the negative. Okay? That's why there's two answers, because when you're squaring things, you can be talking about the negative or the positive. Yeah, what you got? Yeah. But it's two different values because there's other stuff being done to it. Okay? This was just, there's no B there, which is essentially why. But as we transform that quadratic from the parent, it spreads out, stretches out, shrinks in, so that's why they're two different numbers at that point. Okay. I need to make sure everyone in here could find -2 and 3 for that function, the zeros of that function. Everybody okay on that? Yes. All right, so to solve by graphing, all we're doing is making sure the equation equals 0. So that's key now, y'all. Most of the time it is. So solve by graphing, make sure, and this is going to be in general when we solve quadratics other than one way. It's always, we're going to make sure the equation equals 0. We're going to graph, and we're going to find the zeros, and those are going to be our answers.
How is this any different from what we already did?
Because we're using it now to solve equations, to actually solve them instead of just finding zeros. It's making the connection between the zeros being the solutions to the equation. I'm not, your book has you go by hand through it. I'm not going to make you go find them by hand. But, yeah.
If you solve on the calculator, you just solve it algebraically.
You're going to have to solve some graphically.
Yeah, if you solve one of them.
Well, you don't know how to do that yet. All right, you try this one. Yeah. Yes. I'm not going to do F. Let's say x squared. These are very, very basic quadratic functions. Solve for x. Solve by graphing. Okay, so I'm definitely going to want to see a sketch of your graph even though you're using your calculator, right? And I might even say, find the vertex and find the solutions. Or find the minimum and find the solutions, okay? All those are fair game now. It's going to have a minimum, yes. And the minimum is the same as the vertex, yes. But right now, I just want you to solve by graphing. How? You don't have to. I just want you to find the zeros right now. I want you to solve for x. Tell me what x equals. In other words, what could you plug in to make this equation true? What values work? I hear calculator buttons. Isn't it nice to have a calculator that does all this for you? Like, what you mean, which x? You have two answers, so you have to include both.
This is where I messed up last time. I got the first one, but when I try and do the second one.
Okay, so scroll over to the second one.
The second, what, down here?
The second zero. Where is your second zero?
-1.
Okay, put it close to it.
Right
now
there.
go left.
Click enter. Or just,
and now hit enter.
okay.
Go back to it. And then go right 2 clicks and hit enter and enter.
Do you have to do that every time?
Every time.
It's the same thing?
Well, that's one. Then go to your next one and do the same thing.
But it gave me the same.
All right. And I'm glad my calculator did this to show you. We talked about this a couple times. If you see the big E with a negative number, that's scientific notation. Your calculator with the pixels and everything else rounds at certain points. I don't know why. That's 0. Okay. If you ever see a big E with negative something, that's 0.
So if you wanted to find your minimum, would you just go down to the minimum?
So if I needed to find my minimum, Now, remember, you're going to have to show work for this, but to verify that what you've done is correct, calculate the minimum and left of the minimum. So I'm going to go about on the minimum, and I'm going to click left 2 or 3 times, enter. I'm going to go to the right of the minimum, and I'm going to hit enter and enter. And so everything that I am asking you to do right now, you can verify on your calculator. Okay? Now, if you start not showing me any work, I'm going to make you do a non-calculator test. Because I want to see your work, but use the tools that you have to verify what you're getting. You see what I'm saying? We'll get to the point where we will rely solely on the calculator, but right now it's a tool to check what we're doing. Yeah.
How does this verify?
If you plug it back in, just like when you solve a regular equation, if you plugged in, let's say I plugged in -1. -1 squared minus 3 times -1 minus 4 would be 1 plus 3 minus 4, which would be 0. Same thing whenever I plug in 4. Oh, if I asked you to find the minimum, then you would find the minimum. You'd have to do the vertex, but that would check to make sure that your values were correct.
So you would do positive 3 over 2, 1.
Yes, if I was doing the vertex, or if I was asked to find the minimum, then I would do opposite B over 2A, which is 3 over 2, which is 1.5, which is what I had. And then plug it back in to find the Y. Yes?
So you want us to do what we did in 3.1, but then check it using the calculator?
No. We're solved by graphing here. We're totally different. Yeah.
How would show work if we
You'll sketch a graph and show that it's crossing at -1 and 4.
So mine's going to be the right intercept, but it doesn't look like that on the calculator.
Your window's probably set different. It's okay.
But like, it's weird because it's just sitting on the...
Is it crossing the x-axis at -1 and 4? Then you input your equation wrong.
I mean, like, that's where it is, but it doesn't go past it.
I'll have to look at it.
But when I look at the minimum, it gives me the right one.
You're just something. What's your question, Jeff?
So you want us to show plug-in our points that we found?
Yes. Oh, you're talking about the check? No.
Yeah.
Yeah, it's your window. Your zoom's so far in. If you go window and hit C, you're going 1,000, maybe 1,000. You're just zoomed out.
Tally.
What? Negative 1,000? I don't know how to fix it.
Hit standard and enter.
Negative 1,000. This would be.
It was crossing and just you couldn't. All right, yeah.
Will you turn the arrow on? It is.
All right, come on, let's finish this up. I forgot to hit pause in the video. So.
That's 5 more minutes.
All right, let's see. Let's think about something for just a minute, and I want you to think about this with me. Think about it hard. Can you think of a situation when you're asked to solve a quadratic when you don't have 2 solutions? When?
When you don't.
Yeah.
What's the vertex?
0.
If your x-intercept is the vertex, you only have 1 solution, right? 1 solution because I only have 1 x-intercept. I only have 1 value that's going to make it 0. Can you think of any other time when you won't have 2 solutions? What happens here? No solutions. There is no value you could plug in to ever make that equation equal 0. Okay? So just like with lines where sometimes we have infinitely many solutions, no solutions, sometimes with quadratics we have special scenarios that happen, okay? Sometimes there's 2 solutions, sometimes there's only 1, and sometimes there are none, okay? And there's actually not none, they are actually imaginary solutions that we will get to, but not today.
Imaginary.
Okay.
What the heck is an imaginary solution? You just.
America, explain.
All right, let's do another example. Solve by graphing. That's all. Don't let it intimidate you because of the way it's written. That's what Ava said. Just move to one side and she's absolutely correct. Get everything together on the same side. I would go ahead and be in the habit of having your leading coefficient, the number that leads the equation, the number that's hooked to the x squared. Always keep that positive, okay? It's not going to make a big difference when you're graphing here, okay? But when we get to other methods of solving, if you're in the habit, if you have to move, of moving them to where it stays positive, it'll make your life a little easier. So if I move the x squared and I move the 14, keeping it in standard form is also key. Okay? So I have 0 on one side, and on the other side I have x squared minus 6x plus 9. And I was asked to solve by graphing. So I need to graph. How'd I just what? I hit over to the left. Typed over it.
If I ever mess up, I have to clear and read.
Like if I wanted 9 to be 7.
I did not know that.
Oh my gosh,
Clear the
do
whole time.
you know how many times I've had to retype an equation because I kept
Yeah, me too.
there?
I do
Do
that.
it again, Mr. G.
Y'all.
There was an easier solution the entire time.
I would always clear it.
No,
If I messed up like one number, I have to clear it.
Let me give you a hint. Let me give you a hint about finding zeros whenever the vertex sits on the x-axis, okay?
It's the same thing. But
You're not going to be able to call up the zero function. You're not going to be able to calculate a zero here because here's what it does. When you calculate a zero, you have to give it a value that's below the x-axis and a value above the x-axis. Well, this one never crosses over the x-axis. The zero actually sits on the x-axis. Now, some of the newer calculators might do it. Did it? If you did 0, it gave me?
3, 5,
I would just find the minimum. And if you do the minimum, you'll know if it's a 0 because your y value will be 0, right? This is just, should this occur, I don't know. Maybe the newer calculators, they fix that and it does it. I don't know. Used to always be an issue. Again, notice my e with the negative number set at 0. So 2.99999.
Mine is mine around though. Mine always around.
Really? I don't know.
Mine says 3.0001. But then before it says 0.
I've never got that.
So my,
Mine did say like 3.00001, but now it's 3.000.
okay, so I'm wondering if it's a pixelation issue. If you plug in 3 in this equation, does it make the equation equal 0?
Look.
Let's look. If you plug in 3, because everybody's getting, we're rounding to 3, right, as the solution. If we plug in, what is 3 squared minus 6 times 3 plus 9? So x equals 3 is the solution. So you see how you have to use what you know?
There's only 3. There's another solution.
So should we always?
No, it's just 1, 3.
We always round up.
How is it just 1?
I wouldn't say always.
Like if it's like 2.99.
Look what, yes. Look what else I can do. If I go back into that table, second graph, and I hit 3, it's plugging 3 in for me, and what's it giving me? Okay. All right. A golfer hits a ball. Y'all knew I was going to do a word problem. Actually, a golfer hits a ball from an elevated tee box 200 feet above the fairway. Is that a thing? Does anybody play golf? Is that a thing?
Wait, what is it?
You hit it A golfer hits a ball from an elevated tee box 200 feet above the fairway. That's a thing? Okay.
It's like you're hitting it.
I mean, that makes me think like they're...
It's like on different planes.
Here's the golf course. They're standing on a box that's 200 feet high. And he's like hitting off of this...
Yeah.
Love that.
Yes?
He hit it 200 feet.
Like,
So you what, climb stairs to get to the top of the box and hit...
No, it's like a hill.
It's like this, but it's flat.
It's like a little hill.
It's like,
Yeah, no, it's like a hill.
It's a
It doesn't
plane.
mean it's an actual box.
Yeah.
It's not, it doesn't. She thought it was like a plane box. Or it could be
But
like
200
Topgolf.
feet, that's pretty high.
Well, the guys
Tiger.
were Pop Tarts and that.
It's like
I mean, it's
Okay.
like the guy in the prom was like-
you ever been to the country club and the guy would face their arm on? So there's something where like the two boxes up here.
The whole fairway gets.
Yeah, it's a straight.
But you don't have to wait that much increase. You're already on a hill, so it's kind of go up, but it,
Maybe it's 200 feet above sea level.
That's what it
Okay.
Yeah, that's what Common Core math means.
like right when he hits it, it's 200 feet, or that it goes up.
This, okay, so he is standing on a box that is 200 feet above the fairway.
Oh, so it is on the top.
Yeah. Okay. The ball's height above the fairway is modeled by the equation. You golfers should like this. -6, you will see variation of this equation come up all the time.
Golf is not a sport.
That's a T for time. It's in the problem. Time. T is the time in seconds after it is hit.
So this, is that 200?
Okay. That's 200 at the end. All right, let me read the question in its entirety to you so you understand, because this is what it'll look like. A golfer hits a ball from an elevated tee box 200 feet above the fairway. The ball's height above the fairway is modeled by h of t equals -16t squared plus 28t plus 200, where t is the time in seconds after it is hit. How long will it take the ball to reach the fairway?
You're solving.
So when is the height, h is height by the way, they did not define that, but h is height. When is this 0?
So would there be only one solution?
Okay, but think about it.
Starting.
Graph it and see what it looks like.
I think it's going to take my graphic on the calculator. Just happy to re-put like.
Oh, sorry.
Well, I mean, just like.
Woo.
Sorry. Marshall, you are staying on me pretty good there this morning. -16x squared. You can't see it?
It's like. Oh my god. You have to say this is not like.
Mine looks like 2 lines.
Mine didn't work.
All right, listen. Let me explain, guys. All right, I want you to think about a couple of things. First of all, you know enough about quadratics by now to know that 200 is going to be my what? That's my y-intercept, right? So it's not crossing until way up at 200. So I definitely, oh, I was wondering why I didn't see it. Thank you, Dave. Also understand, okay, so it's going down because it's negative. So my vertex, my maximum is somewhere way up there, right? I don't need that for this problem. I don't even need to adjust my window. I'm gonna assume it's way up there somewhere. I also don't need any of this over here, right? Do you understand why?
Because you're already up there.
Well, this is my x-axis is my time, right? And my y-axis is my height.
You can't go negative stuff.
I can't have negative time or negative height. So this is a real world problem that's only in the first quadrant. First quadrant's the only one that counts here, right? So you only have one solution. You can't hit the ball -10 seconds, right? Or it doesn't hit the ground in -10
so it's gonna
seconds.
look like this. You can just.
And the reason it's up here is because you started a height of 200. If you'd started with the ball on the ground, then your function would be coming up through 0, 0. You'd start at 0 height, but because you started, so when you hit it, it's just falling, right? It's going up a little bit, but then it's just falling. Because that's what it does.
Okay.
So this is a variation of our gravity equation. That's the negative 16. Okay, so calculate the 0.
I'm trying to get my first show. I won't even graph it.
Hit zoom 6.
Whoa. That's those error things
That means you input the equation incorrectly. I bet in front of the 16 you put a minus sign instead of a negative sign.
I did that too.
4.5. Okay, I got it. Thank you.
Fine, I'm calculating the 0.
That's what I got.
So how long does it take the ball to hit
Good
the
morning,
ground?
Cameron High. It's time for the morning announcements. Please stand for the Pledge of Allegiance.
Today passed quick.